afternoon. Thank you all for joining us. Welcome to the first of the West Marine Pro Tips to the Trade webinars that are happening all month, every Tuesday. We're joined today for the West Marine Pro webinar by Danny Asensio Hall, the National Sales Manager from Power Products, and he'll be talking about battery chargers for a variety of applications. If you have questions throughout the presentation, please write them in the chat box, which should show up at the bottom of your screen. And at the end of the webinar, we will answer the questions that you may have. Thank you to West Marine Pro for arranging all of the webinars. And with all of that said, I'm turning it over to Danny to begin the presentation.
All right, thanks Michelle, and welcome everyone. Good morning, good afternoon, depending on where you live. Thanks for joining. This is going to be about a 25-minute presentation on battery chargers. I've done a 3-hour presentation on battery chargers, so this is going to cover the highest level, but I do urge you to ask questions in the chat box. I will be monitoring that. Feel free to ask questions at any time, and I will try to answer them while we're on the appropriate slide. Otherwise, we'll try to cover everything at the end. So I think it's always important to understand the highest level of what something does. I think point number one, everyone is very aware of, which is a battery charger's job is to properly charge a battery. The thing is almost every battery charger can charge a battery, but if you have different variants of price point in charger, like why would a charger be $1,000 versus $200? That's because the charger is going to help prolong the life of the battery. And it's really important to do that, especially if you're spending a lot of money on batteries, like a lithium battery or an expensive 8D AGM battery. You want that battery to last as long as possible because you don't want to have to move it in and out of the vessel with any kind of frequency. So prolonging the life of the battery is what I believe almost as important as charging it. And we're going to go through the details that help battery chargers prolong the life of the battery so you can make the right choice for your applications. So first and foremost, there's two primary kinds of battery chargers in our industry. There's a vented charger, which has a fan that ventilates air throughout the charger to cool down the circuit board on the right-hand side. And then there's a waterproof battery charger, which is a fully sealed unit that can actually get wet while the boat is underway. They're very different, and I think it's important to understand why you can't use a waterproof charger in every application, as well as why you couldn't use a vented in every application. So on the waterproof charger side, first and foremost, there's a maximum battery bank size that each output can be connected to, and that is group 31. So there's individual leads that come off of a waterproof battery charger. You cannot attach those to a 4D or an 8D battery, or you will run the risk of actually burning that charger out. It is not designed to be able to dissipate enough heat to charge a battery larger than a group 31. So if you have a 3-bank waterproof charger, you can have 3 group 31s, but you couldn't have any one of those batteries be larger than a group 31. And that's where a lot of people run into issues, is they just put these chargers on large center consoles that have bigger battery banks, bigger house banks, and they think it's going to work because they used it on a 22-foot center console. But because the battery is larger, it isn't going to work. And that's the #1 distinguishing factor that I want you to take away with. Mixed voltage applications, waterproof chargers are perfect for. You're probably known for 24 and 36 volt trolling motor applications. That's where waterproof chargers thrive. And there's also going to be the ability to still charge a 12 volt start battery. So applications where there's multi-voltage on a smaller boat, that's a great application for a waterproof charger. They're never intended to be used as power supplies. I always like to give the example that I have a buddy who lives in South Florida, and he actually went to the Bahamas for a 4-day weekend, and he ran his bait pump the entire time he was attached to the dock in the Bahamas. Now, the waterproof charger was essentially supplying that power to the bait pump, and he burned it out. And that's because the charger is going to charge up the batteries and then just maintain the charge. It's not meant to supply current to devices for an extended period of time. So if you have an application, even in a smaller boat where you know you're going to require a power supply, you wouldn't want to use a waterproof charger. Typically, a waterproof charger is going to be in a trailer boat where the only AC device on board is the battery charger, and you're going to use an extension cord to plug that in. If you have a hardwired electrical panel, that is usually a case where you would move to a vented charger. We're going to talk about temperature compensation later in the presentation, and that's going to how it helps prolong the life of the battery, but rarely do waterproof chargers have it. There are a couple of chargers on the market that do have temperature compensation, but it is not common. Last but not least, when you have a waterproof charger, sometimes you don't even get to pick the chemistry that you're charging. They're just defined as you buy that charger and you hook it up to a battery. But other times you're just selecting the chemistry of the battery. You're not doing any customization of the voltages that that charger is going to charge at. On to vented, which is going to pretty much be the opposite. There's no battery size limitations. So any batteries larger than a grid 31, that's where you're going to use a vented. No amp hour maximums. Typically, 98% of the time, a vented charger is only going to work with a single voltage. So all 12 volt banks, all 24 volt banks. Very rarely can you have a charger do multi-voltage. I will show you one charger later today that has that. Ideal for power supplies. That's why it's great on larger boats that are going to have active loads running when you're at the dock. They're always hardwired into electrical panel. You're never going to see a plug hanging out of one of these that you plug into an extension cord. It needs circuit protection in the form of an electrical panel. They almost always have temperature compensation because they're charging larger, more expensive batteries. They want to maintain them properly, so they're going to properly charge them based on the battery's temperature, and they will come with a temperature sensor. And then they're great at charging unique chemistries. This is where you're going to get into your lithium ion because you can customize the charging voltages, and we're going to show you how that works a little bit later. So going into waterproof chargers first, I think it's good to kind of orient yourself of what type of boats are going to have these chargers. I think we're very familiar with waterproof chargers. You can see all these boats are open boats, have the potential of getting wet, have smaller battery banks, and of course in the bass boat application is most likely going to have a trolling motor that could be 24 or 36 volts, so that mixed voltage application. Wiring a waterproof charger versus a vented is extremely different. So a waterproof charger, because it's fully sealed, actually has wires that come out of it that are sheathed and protected so that we can control the water that's going, is not penetrating the charger. And each of those wires has a positive and negative. And as you can see on the left-hand side, you're going to wire up the batteries with a positive and negative for each of those outputs. Now, the charger doesn't care what voltage those batteries are, if those voltages for those batteries are in series. So on the right-hand side, you can see the same three batteries, but the two batteries on the right are actually in series, connected for a 24-volt bank, and we maintain the 12-volt bank on the left. You can see the wiring of the charger is the same. It charges each battery like it's an independent 12-volt battery, where a vented charger will not do that. So you can see this is a great application for mixed voltages. A common question I get is, what happens if I buy a 3-bank charger but I only have 2 banks? You don't ever want to leave loose cables laying in a wet bilge. So you actually want to take those ring terminals from the spare output and stack them on top of another battery. Depending on the style charger you have, that may double the output, but other chargers, it won't matter. It's just a safe place to install them so you don't have loose wiring hanging around. So just keep that in mind. Those ring terminals always need a home on top of the battery. So these are the two primary types of waterproof chargers in the market, and how they charge is really the difference. They're both waterproof. These are both 2-bank chargers in this example here. On the left-hand side, we have a 12-amp 2-bank charger. On the right-hand side, we have a 10-amp 2-bank charger. So very similar in terms of output. On the right-hand side, the charger has an isolated output. So even though the total charging for the whole charger is up to 10 amps, it can only do a maximum of 5 amps per output. So you can see that battery on the left has 5 amps going into it. It's deeply discharged, but the battery on the right was probably the start battery. It's full from being charged off the alternator. It does not need 5 full amps going into it. So the charger derates it and just maintains it with 2 amps. So you can see though, out of the total 10 amps available, we're only using 7 amps. So we're actually underutilizing the maximum capacity of the charger. So this is just going to result in longer charging times. So because it's an isolated output, it is most likely a less expensive product. Now comparing that on the left with a 12-amp charger, this has distributed on-demand technology. So that means that full 12 amps can be distributed to whichever battery actually needs it. So you can see the battery on the left, the same deeply discharged battery is getting a bulk of the charge with 10 amps coming out of the charger. And then we maintain that starting battery on the right with 2 amps. A total of 12 amps, there's no amperage being wasted. Again, this product will probably be more expensive when you're comparing chargers against each other. That's most likely going to drive the decision in cost. But if you're just someone that's going to vote once a month, you don't need to worry about charging so rapidly, and the one on the right may make sense for you or your customer. But those are the two primary types of waterproof chargers and why you would see different price points between the two. Now, I think it's important to talk a little bit about how the battery chargers work. I don't want to get into super detail here, but at a high level, it's important because we want to understand when you're selecting chemistries of batteries, what you're actually doing when you make that choice. So you can see the three different stages that most people have heard of: 3-stage battery charger, 4-stage battery charger. Every battery charger out there has the bulk stage, which you see on the left, which is where we're just dumping current into the battery to get it charged as fast as possible. That is going to happen until you're about 75 or 80% full. It's just like the water analogy. At that point, you're going to slow down the amount of power going into the battery, and that way you don't overcharge or overfill the bucket that the battery is. And then you're going to move into absorption. Now, absorption is going to occur. This is a 3-bank battery charger example, based on the needs of those discrete batteries and those discrete banks. And that's going to happen until we hit that absorption voltage. So on the right-hand side, that's 14.4. Now, if you selected the AGM setting, this absorption voltage is hard to find in the battery charger. You don't need to worry about what that voltage is. The manufacturer of the charger has selected those points for you. And when the battery hits 14.4, we will now call it a fully charged battery, and it will drop into what's called a float mode. And float mode is just a maintenance mode. It's just keeping a surface charge to make sure that the battery is fully topped off and ready to go when the charger is disconnected. Now, in between that, a more common term being used in the industry is pre-float. And that is an intermediary step between absorption and float. And that's for multi-bank chargers. Like in the previous example where batteries were charged at different levels, absorption is going to end at different times. And so the last thing you want to do is continue to charge a battery that's already full because another battery on board is not full. And so what we can do is actually drop to an intermediary step where we lower the voltage to prevent overcharging on those discrete batteries. And then when the final battery is full, we'll drop fully into the float mode with all three. So that's a typical battery charger and how it works. And when you select AGM or gel, those selections are being made for you in a waterproof charger. Here's an example of what it would look like. This is just a screenshot from one of our chargers. Now, if you selected AGM on the left-hand side, that's likely all you would see in a waterproof charger. You would probably be pushing a button and an LED would be turning on. On the right-hand side, this is what's happening in the background when you make that choice. It's hard to find that absorption voltage and the float voltage. So when we get those different levels, the charger will move into those different modes. I wanted to cover that before we move into vented chargers, because that's where we really start to differentiate ourselves in how vented chargers charge. So first, here's the boat types. So you can see much larger boats. These are boats that are going to have bigger house banks, more auxiliary loads. Maybe there's a refrigerator, an air conditioner, things that require a lot of power that are going to run continuously even if you're at the dock, like a freezer. Bigger sailboats, cabin cruisers with a lot of loads, and I really think it's important to outline large center consoles. I have a lot of people that owned a small center console, moved to a large center console, but now they have air conditioning. Now they have a freezer for their bait on board, and those things need larger batteries and need larger battery chargers. So larger center consoles are definitely a good application for vented chargers, and there's still places to install them inside the console that you can be away from moisture. Now, vented battery chargers are wired very differently. So we talked about how multi-voltage was great for waterproof chargers. Well, that's not going to be the case in a vented charger. So you can see here, this is a 3-bank charger, and all 3 banks are the same voltage. And we know that because there's a common ground. So that common ground exists between all of the batteries. The charger will not work if one of those batteries does not have a common ground. It won't properly charge that battery because it doesn't know that it's in the system and in the circuit. All vented battery chargers have distributed on-demand technology. Whether it's a 2 or 3-bank charger, it is going to divert the total power available, let's say 40 amps, for example, to the battery that needs it most and utilize all that power if the batteries need it. Also, same chemistry is very often required. That question of, can I put an AGM battery for my house bank and a flooded lead acid for a start? Typically with a vented charger, you're not going to be able to do that. And with most vented chargers, again, lithium battery for a house bank, flooded lead acid for a start, that would be a situation where you need to consider two different charges. But there is a charger on the market, most recently, the ChargeMaster Plus, that can do multi-chemistry. And in this example, the two batteries on the left are lithium ion, and the battery on the right is an AGM, that's the start battery. This charger, because the third output is actually isolated, can do multi-chemistry. Charles used to be able to do the same thing with some of their chargers. So a very, very small amount of the market has this available, and I just wanted to point it out. This charger also allows the ability for the alternator to when it's running, to actually grab power and distribute it back amongst the batteries, not just the battery that's tied directly to the alternator. You can see the alternator feeding back up into the charger there and distributing it amongst the other two lithium batteries. So there are a couple of chargers on the market that do it, but for the most part, vented chargers are going to not allow you to do mixed chemistries. Again, I wanted to touch on the different absorption voltages here. So before, with the waterproof charger, you were selecting a chemistry and those voltages were defined. You probably didn't even know that there was necessarily voltages behind those selection choices. Now with the vented charger, let's say you're charging an Odyssey battery or something that's more specialized that is expensive. You can actually go in and make those custom voltage selections. So on the left-hand side, there's your typical AGM and it's hard-coded in the charger. On the right is a vented charger that lets you customize those voltages. This is what Odyssey recommends their batteries be charged at. Yes, Odyssey is an AGM battery. It's a derivative of an AGM called the thin plate pure lead, but it's still an AGM at the end of the day. So it would be easy to see why someone would make an AGM selection. But as you can see, there's a massive difference here between 14.35 and 14.7 for absorption voltages. And you may go, you know, that's a fraction of a volt. That's not a huge deal. It is over the life of a battery. Over 5, 6, 7 years of the life of a very expensive battery, those details will add up. And again, we want to prolong the life. So it's important to use the battery manufacturer's recommendations, if you have a specialized battery, to set these voltages. The other really important piece to keep in mind if you're using an expensive battery is to consider temperature compensation. Now, a battery charger is going to have temperature compensation if it comes with that little temperature sensor that you can see on the right-hand side of the screen there. So that is going to actually attach to the battery itself, and that's going to monitor the temperature of the battery. Now, it doesn't make sense that a battery in the middle of winter in Alaska is going to be charged the same as a battery in South Florida in the summertime. Those environments are so different. And when a battery is charged, it's a chemical reaction occurring. And that chemical reaction can produce heat. So in order to optimally charge the battery, we have to take into account the ambient temperature. And this temperature sensor allows us to do that. So almost all battery chargers that have temperature sensors use a baseline of 25 degrees Celsius. That's right around 70, 75 degrees Fahrenheit. And if the battery is over that threshold, the voltages will be reduced when it's charged. So in a hotter environment, the charger is going to charge at lower voltages to try to reduce the heat being produced in the battery when that chemical reaction is occurring. And then in a colder environment, we're going to pump up the voltages so that we can actually create the optimal temperature so the battery is charging most effectively. So I lived in northern Washington, and in the middle of winter, you could see normal batteries being charged above 15 volts because it was almost freezing outside. And that's because of temperature compensation, optimally charging those batteries. A lot of times, they're like, you know, I don't want to run that temperature sensor. It's annoying to put on the batteries. It's a far run. It actually makes a huge difference over the life of the battery to install that temperature sensor and make sure that the charger is optimally charging those batteries. Now, you're most likely not going to remember everything that I say here today, and that's okay. But we've partnered with West Marine to make these choices easier so that when you walk into a West Marine store, you're going to actually have a sign above the chargers to make it easier to pick the right charger for you and your customers. It's a very simple 3-step process. First, you orient yourself with the style boat that you have. On the left-hand side, we have a waterproof charger that's going to be mounted on an open boat. On the right-hand side, you can see a larger cruising boat. So you know right off the bat, based on boat type, which side of the chart you're looking at. Then it's a 3-step process. How fast do you want the charger to be charge your batteries? Maybe you're a weekend tournament fisherman. You want to be charging as fast as possible. What chemistry are you charging? And then what type of batteries? And how many batteries, of course, if the bank size matters. Now, the biggest question I get is, what about amperage? There's a lot of 2-bank chargers out there. Why would I pick a 10, a 12, a 15, or a 20 amp? Well, that's going to depend on the batteries that are on board. So there's a general rule of thumb of between 10 and 20% of the amp hour capacity. So in an example, you have 2 Group 31s on a boat. That's around 200 amp hours combined. 10% of that would be 20 amps. That would be the size charger that would be appropriate for you. And just so you're aware, you can really never oversize the charger. Price usually becomes the limiting factor, but you can always get a larger amperage charger. It will charge your batteries faster as long as it's the right kind of charger for the boat. I wanted to touch on inverters and inverter chargers because they go hand in hand. Now, inverters, of course, are producing AC power off of DC power from batteries. And so this, again, are going to be larger boats. I added in the sport fishing boat because anyone who wants a generator alternative, sportfish frequently have generators on board. An inverter charger can be perfect for them. You'll also see our friendly little pontoon boat in the bottom right-hand corner. That's on there for one reason only. Blenders and barbecues. The party barge is out there and they need inverter power in order to have all of their toys on board and then making them run. Inverter, like we discussed, is converting DC power to AC power, which is what you get out of your house. There's 2 different kinds of inverters, a modified and a pure sine. Pure sine is that smooth blue sinusoidal wave that you see on the chart there. And then the red is a modified sine. It's essentially a modified square wave that chops off the rounded curves of the pure sine. Now, everything you're buying to plug into AC power is meant for pure sine. It's meant to be plugged in at your house. So when you're plugging it in on your boat and you have a modified sine wave inverter, it may not work optimally. So it depends on what you're plugging in. Motor-based loads like blenders or drills, they really don't care. They're just going to run as long as they have the voltage there to be powered. So you can get away with a modified sine wave inverter, which is less expensive. Things that have sensitive electronics like laptops and TVs, they need pure sine. They're designed to be used on the North American power grid. So that's where you're going to want to go with the pure sine. We're getting close to running out of time here, so I'm going to start increasing speed. So first and foremost, inverters are rated based on wattage, where chargers are rated on amperage. So 1,000 watts, you're going to need at least 1,000 watts to power a 1,000-watt microwave. So they go hand in hand like that. The other piece dropping down at the bottom of the slide to keep in mind is the more wattage the inverter has, the more battery power you need to support it because the batteries are powering the inverter. So here's a very easy example. 1,000 watts of AC power is 8.3 amps at AC. 1,000 watts at a 14-volt system or a 12-volt system is 71 amps of DC power. In a Group 31 battery, that means you're going to drain this battery to 50% in about a little over a half an hour. So you can see how fast an inverter can drain a battery, which is why it needs larger batteries to support it. Now, an inverter charger is something you could keep in mind for you and your customers because it is essentially an inverter and a charger. Very obvious there. But what you get is more power for less money. As you can see, a standalone inverter and a vintage charger would be around 2,000 watts, 75 amps of DC charging for $1,600. But with a combination unit, you get 3,000 watts, 160 amps of charging for less money. So a customer that's considering adding an inverter or upgrading a larger battery charger, it may make sense to do a larger upgrade to an inverter charger where they get more bang for their buck on doing that install. Again, you're not going to remember everything I said here. So in most of the West Marine, especially larger West Marine stores, there is a sign to help you pick the right inverter charger for you and your customer. Of course, what device you're powering, do the loads need to be directly connected into it, like that blender application on a pontoon boat? You're going to want the GFCI outlet on the inverter itself versus hardwired into an electrical panel. And then, of course, how much power do you need? What devices are you plugging into it? The wattage rating is right on the appliance itself. Make sure you get an inverter that can handle that continuous rating on the appliance. I think we just snuck in there, a minute over 25 minutes. My contact information is on the screen here, and I don't see any additional questions, but if you had any, please write them into the chat box now, and you're more than welcome to reach out to me if you have any detailed questions through this email address. And I wanted to thank you personally for attending and hope that you're staying safe.
Okay, if anyone has any questions, please put them in the chat box. We'll give you a couple minutes to do that. Thank you to Danny for joining us today, and to Power Products, and also to West Marine Pro. I do not see any questions, Danny, so hopefully people will send them into your email, and
we got one.
Here we go. Can you see it, or would you like me to read it to you?
I can see it.
Okay.
Yeah, a semi-portable charger solution that can handle relatively large banks that can get taken ashore as well. I would say, honestly, we have to talk about amperage, but if you need a larger amperage charger, the waterproof chargers are going to be the most semi-portable because the wiring is physically attached to them. There are portable chargers like with the clamps that you would see at an auto store. They're typically not marine rated, but you can get those up to 30 amps. I believe West Marine actually carries a 30 amp portable charger. That may work as long as it's 12 volts. You could go with the portable route through the West Marine product, or you could consider a waterproof charger that you could actually take the range from almost off of the battery itself. Oh, I see. Race applications, got it. Where you're trying to remove weight. Yeah, I'd say a waterproof charger would make sense because it's not like they're running. It's a really quick change. They have a few minutes to do that, or a large one. Unfortunately, most battery isolators work on the same voltage. So if you have a 12 volt start battery and you wanted to charge a 36 volt trolling motor, you wouldn't be able to do that. There are some products out there that convert, they're DC to DC voltage converters that would allow you to do that, but a typical charging relay, an ACR, a VSR that you would see in most stores cannot do that voltage change. They need to be at the same voltage. So there's not a lot of products out there. There's maybe one or two on the market. They are more expensive. They're for tournament fishing applications.
Danny, there is a question on if the presentation will be available or downloadable after today. We are recording this webinar, and the webinar will live on westmarinepro.com, but I don't know if you want to contact Mark directly, who's asking for this, or speak to the presentation itself, or if you want people to contact you for the presentation.
Yeah, if we have the email addresses of everybody, we can easily send this out. Or if you want to reach out to me directly, I'd be happy to attach it.
Under Q&A, there are a couple of questions.
Q&A.
And one is on preferred maker of solar panels.
That's a deep question. We have no preference on manufacturers of solar panels. I believe that the photovoltaic cells are actually manufactured in only 3 locations around the world, like Samsung. So I think most solar panels are very similar. It just depends on if it has the right power rating for your application. So there's no preferences there. This other one from Chris about a blue sea isolator being worth it. Absolutely. You know, charging a secondary battery off of a single engine charging source definitely makes sense to have some kind of combining solenoid, ACR, VSR. It's the best way to maximize the power you have, and while you're running that engine, you're burning fuel, you might as well get power out of it for all the batteries on your boat, not just the starting battery.
And there is one more additional question under chat as well. from Jonathan Kabak.
Reading it now. I don't think consistent brands matters that much on keeping the right battery and battery charger. It only makes sense if the battery is directly communicating with the product. Like, let's say you had a lithium battery that speaks on a network, like a CAN bus network or a NEMA 2000 network, then you would want the charger to be the same brand because they speak the same language. But if you're charging a flooded lead acid battery, keeping that battery at the same brand as the charger is not necessarily a requirement because those products are not talking to each other. So I think it depends on if you have a very advanced battery that is speaking in a protocol.